Alright guys, this is kind of the overview for the passive solar / conservation of energy lab. We're going to be building a little small scale model home to demonstrate kind of some of the passive solar and energy efficiency and conservation things that we're studying in these chapter 12 and 13. Here are the specifics. You need a minimum of 50 square inches of window area, so that implies that you're going to be drawing out some plans. Your windows have to be kind of big. You know how to calculate area, right? This is like the length by the width. Right, so you can do that. It's going to be in inches. People in the house must be able to have natural light during the day. That means you need to have windows. Obviously, if we don't have light, you're going to have to use electricity, so we don't want that. There's a really good example of this, like a San Francisco science school that you can look at the end of, I think, chapter 12, which kind of takes advantage of a lot of natural lighting. You don't want a house that's too large. It's very difficult to heat or cool. Your model is going to be about a foot tall. Less than that, right? Temperature probe is going to be kind of in the middle of the house. It's going to look kind of like this. See on this page. So we're going to have like a light for summer. It's going to be high up in the air. 22 inches up in the air for summer. 12 inches for winter, and that's supposed to simulate the angle of the light hitting the house. So obviously if you have like this nice roof coverings overhang, it's going to help you, right? So you want to include that in your model. There's some demonstration models in my classroom that you can look at and kind of copy if you want to, and just see how you do from there. These are the materials that you can use. Yeah. Your walls may be no more than 1 inch thick. Exterior landscaping is not allowed to interfere with the light hitting the house. So you kind of have trees that are blocking out the sun, even though in real life you could. This is just looking at the base model of the house and seeing like how well it would do without anything else. All right, so let's see. Here's some of the materials you may use: cardboard, styrofoam sheet, foam board. Flooring can be cardboard. You're not being held accountable for designing the interior. So I'm not judging your design of the interior. So don't worry about this. It's really the exterior that we're looking at. So you can use tile if you want, but just keep in mind there is kind of a weight limit. I'm not going to let you do more than about 1 to 2 kilograms. If you're using like a gigantic tile for that, it might make the temperature, or it might make the mass really high. If you do some linoleum, this might be a better bet for some of y'all. Linoleum is pretty easy and inexpensive to buy. You can cut it up into a lot of different shapes. Windows, you may use acetate plastic or just some sort of plastic covering that you can use, just something that's clear. If roofing, you may use white or black shingle. So think about which one might help you more in terms of heat absorption and reflection of heat. You bring some waterproof material. Try not to spend more than about $5 for any person. And try to use recycled material as much as possible. And for part of our project, I want you to use recycled material and research and compare it to actual recycled materials that we use in real life. So like, what do they represent, right? So we're making comparisons. What do our materials what do they represent? So research some stuff. You need to do this for at least 3 materials that you use. What would these materials represent? Okay, so we're going to be using hot glue. Put it together. You can use super glue if you want. It's really up to you. So this is kind of how it's going to look. We're going to place the lamp roughly about this much. But either way, what we're going to do is we're going to just make sure, at the very least, that it's constant for everybody. We're going to make sure that everybody has the same things. Okay, at the end, you're going to have to do a write-up. At the beginning, you have to design and tell me the reason for the materials in your write-up, and the plan of the house has to be approved before you can do anything. So tomorrow in class, or the 31st, you're going to be doing your design with your group, and by the end of the period I need to be able to approve it and say like, okay, this is good. And remember, your house is going to be 1 square foot for the floor plan, the area, 1 square foot. and no more than about a foot high. That kind of gives you some wiggle room to be able to do some stuff with convection, hopefully, right? And so you're also, in your write-up, you're going to talk about how well some of the things worked in your opinion. And what you're going to do here is you're going to compare yours to others, and that will kind of help you and give you a basis, right? Because if we just did like one group all day and tried to see like how well you think, ice worked for your walls, like you wouldn't know because there's no basis of comparison. And then after that, after you do your comparisons, you're going to look for suggestions of improvement, whether it's the design or whether it's the materials that need to be better. And now here's how it's going to work. Your performance, 8 points for summer performance. So if it does reasonably well compared to others, it'll get 8 points. 8 points for winter performance. And really what I'm going to do here is I'm going to take this out and just make this into, just for doing the lab and having something done, I'm probably going to give you these points. You shouldn't have something that's off by more than about 20% of the average of all of the groups. So you don't want to be outside of 20% of that. We're really looking for within 5 to 10%, hopefully. If you have something like that, if you have something that's really obscene, I better see some good suggestions for improvement in your write-up. But the goal of this is to successfully implement things that you're studying, right? So if you're not getting something that's at least kind of on par with everybody else, then it's kind of question whether or not you're actually taking the studying seriously, right? So make sure you get something that's going to work. All right. So you need here energy saving innovations. You get points for that. 5 points for the aesthetic appeal. And what I'm going to do with this is I'm actually just going to say the best house is going to get 5 extra points added on. And from here, the best performing winter and summer is also going to get another +5. This right here is peer-based evaluation. So this is your peers are going to judge. And this is for all 3 of my classes. This is not per class. Neither one of these is per class. This is out of all 3 of your periods. So this is from all 3 periods. It's from all 3 periods. Okay? All right. Okay, then you'll have a write-up, and you're getting an additional 7 points for completion. So we're taking these out. You're going to get whatever the remainder is from this will be just for actually having the house built. So let's see what this comes out to. Let's see. So let's say the model is going to be 60 points. If we're actually doing the house, this is 60. So that would leave 40 for the write-up. It'll be 40 for the write-up, which includes this guy right here. So let's say each one of these is 8 points. We're going to take this out, 8 points. 8 points here. 8, 8, 8, 8, 8. And then we'll do +5 for each one of these, so you can get a total of 110. 110 for that, if you happen to have the best of each one. Okay, and what we're going to be doing to do the best performance is we're going to take the smallest change from here for each one of these. Okay, smallest change for each one of these. All right. Okay, clear as mud. Great.